Hello there. This is a geometry video. It is chapter 4, section 1, and today we are classifying triángulos. So let's jump on board right away. The first thing I want to talk about before we get started on classifying triangles is to refresh your memory on how we identify different parts of a triangle. Excuse me. Every triangle is going to have vertices, sides, and angles. So I want to start with the vertices. If you wanted to name the different vertices of a triangle, it would be vertex A, B, and C, for example. But what if you wanted to name the angles? Recall that you could name the angle A, angle B, and angle C. But you could also name angle A, angle B, A, C. You could do that. Or it could be called angle CAB. And then for angle B, you could call angle B angle ABC. Did I say that right? Yes, I did. Or you can call it CBA. Angle CBA. Which is all stuff we've already done in the past. I just want to remind you about that kind of thing. Angle C would be ACB. A possible name for it would be ACB. Or it could be BCA. The key is that for angle A, the middle letter is A in both of the alternate names. The key for angle B is that the middle letter is B for both alternate names, and the same is true for angle C. It is in the middle for both alternate names of angle C. You can also name the sides of the triangle. So for the sides, remember the sides of the triangle are going to be segments. So you could have the first one here, segment AB. You would also have segment BC. And then, of course, the longest segment here, segment AC. Alrighty? So I just want to make sure that you know how to name the vertices. They're points, point A, point B, point C. Angles, you have different options for how to name the angles. And, of course, how to name the sides, because it's important for you to be able to do that as we move forward and classify triangles. So we can classify triangles in two ways. So let me get rid of this little slide here. We can classify them in two ways. And the first way that we classify triangles is by angles, by the type of angles that they have. So here are all of our options for classifications of triangles by angles. You have an acute triangle, and in an acute triangle there are 3 acute angles, so all 3 angles are less than 90 degrees. You have an equal angular triangle, and in the equal angular triangle all of the angles are equal, which by the way would make them all 60, right? Because 60, 60, and 60 would be 180. So 3 congruent acute angles. For an obtuse triangle, you can only have one obtuse angle in an obtuse triangle. And that should make sense because an obtuse angle would be one that is greater than 90. So if you had 2 angles that were greater than 90, then you would already be exceeding your 180 degree limit. So you can only have one obtuse angle in an obtuse triangle. And of course, our right triangle has a right angle in it. And down here, I don't know if you can see this really clearly here, but this is kind of important. An equal angular triangle is a special kind of acute triangle. So technically, because all of these angles are acute, it would still classify as an acute triangle. Alrighty? So those are our classifications of triangles by angles. So we will now go to example 1, where it says, use the best description to classify each triangle, whether it's acute, equal angular, obtuse, or right. So we look at part A. And it says that we've got 70, 70, and 40 for our angle measures there. And since all of those angles are acute, we have 3 acute angles in this triangle. Then that means that our classification is going to be acute. I think of the word acute and I think, oh look, it's so cute, it's little. But there you go, an acute triangle. Over here for part B, we have 90, 60, and 30, so this has 2 acute angles. By the way, a 90-degree angle is not considered acute. It has its own special name, it's a right. So because it has a right angle, right, we're going to call that a right triangle. So this guy is a right triangle because it has a 90-degree angle. And then that one was acute. So that's basically all you have to do. It's not complicated to do. So we're going to have you try this do-it-yourself number 1, where you're classifying these 2 triangles, and then we're going to move on to the next example. So in example 2, it says classify triangle PQR as acute, equal angular, obtuse. All right, so basically this is the same thing that we were doing in example 1. The difference is that the diagram might have a little bit more going on than the example previous this one had. In other words, we're looking at 2 triangles inside of the larger triangle, so it's important that we understand what they're asking us for, because they want us to know to classify PQR. So here's PQR, those are the vertices. So I'm not interested in PQS, I'm not interested in RQS. I just want to know PQR. So for P, that angle is 45. For R, that angle is 31. And for Q, we have a combined angle of 45 and 59. So 45 and 59 is going to give us an angle that is going to be 104 degrees. So 45 plus 59 is going to equal 104 degrees. That angle is an obtuse angle because it is larger than 90. So because these are 2 acute angles and you have 1 obtuse angle, then your triangle is going to be obtuse. And so for explaining my reasoning, well, I just explained it because this angle is 1 obtuse angle. We're going to call it an obtuse triangle. All right, so that's that little guy. And we're going to use the same diagram. And you are going to try to now classify PQS. So this time you're concentrating on this angle right here as opposed to the big angle. Alrighty? So then we're going to go to the other method of classifying. We said that you can classify 2 different ways. The first way is to classify by angles. The second way is to classify by sides, by the type of sides that it has. Alright, so we have 3 options for that. We have an equilateral triangle, which basically means equal sides. Lateral means side. So equilateral means 3 congruent sides. An isosceles triangle has at least 2 congruent sides. And a scalene triangle has no congruent sides. So I want to focus one more time on this statement right here. It doesn't, a lot of people think that isosceles means it has to have just 2 congruent sides. Technically, an equilateral triangle can be considered an isosceles triangle because an isosceles triangle says that it has to have at least 2 congruent sides. So it can have 2 congruent sides or it could have 3 congruent sides. And since an equilateral triangle has 3 congruent sides, it qualifies as an isosceles triangle as well. So those are our classifications for sides. And so now we're going to go to example 3, where it says classify the sandbox of the Russian lute. I have no idea what that is. I can see it right there, but it still looks kind of weird. It kind of looks like a guitar, but my husband assures me it's not a guitar, but it's a Russian lute, whatever. So there it is, and it's telling us to classify the sandbox. So I'm guessing that they're talking about this triangular looking portion of the Russian lute. And they want us to classify it as equilateral, isosceles, or scalene. And so they've given us the lengths of the sides. So it's got 16, 16, and 18.5. Since 2 of those sides are 16, that means it has 2 congruent sides. So as long as it has at least 2 congruent sides, we're going to call this an isosceles. And this is one of the weirdest spelled words ever. I always want to call it isosceles. Isosceles, I don't know. I'm not exactly sure why it has SC there. Esca. But isosceles triangle for that one. And so, again, this is not a very difficult section, but you can now try this little guy. It says classify the button in the picture by its side. This is, in fact, a button of some sort. You're supposed to push that button for some kind of a hazard. It looks like that's like a little hazard symbol there. But again, the dimensions of the sides are given. So based on it, they want you to classify the picture, the triangle in the picture by its sides. So once you do that, we can go to example 4. And in example 4, it says, if point M is the midpoint of JL, so here's point M, and it's the midpoint of JL, classify triangle JKM. So here's JKM. So we want, in this diagram, this little guy right here. I'm trying to highlight this guy for you so you can see what we're doing here. That's the triangle we're looking at. They want us to classify JKM, and they're telling us that M is the midpoint of this segment JL. So here you can see in the diagram that JL has a length of 1.5, which means that if you take 1.5 and divide it by 2, you're going to get 0.75. So this piece right here, JM, that segment is 0.75, and JK is also marked as 0.75, and then you have KM and ML are both marked congruent, and since JM is 0.75, it also means that ML is 0.75 because that's what it means to be the midpoint, and so both of those pieces are 0.75, and since these are marked congruent, this segment is also 0.75. So at the end of the day, we have 3 congruent sides, and so therefore this triangle is going to be equilateral. Woohoo! So there you go, and I hope that you understood the explain your reasoning part. I think I was pretty clear as to why that happened. And so now we're going to have you try to do it yourself, number 4, where you're now classifying KML. So I'm going to help you out a little bit by highlighting the triangle that you're supposed to be looking at, which is right here. You're trying to classify this triangle right here. Alrighty. So you already have the information from the previous example to help you out with that. But there we go. So I will now go to our last example, I believe, which is find the measures of the sides of isosceles triangle ABC. So we have this diagram, and they're telling us that this triangle is isosceles, and you can see the little tick marks here. That's telling us that these 2 sides, segment AC and segment BC, are the congruent sides of this isosceles triangle. So that means that they should equal each other. So based on that information, we know that AC should equal BC. Oops, I think we're still running on a highlighter mode. There we go. AC is equal to BC. So that means that the expression 4x plus 1 would equal the expression 5x minus 0.5. And then we solve for x. So we're going to move these 4x's to this side. And when we do that, we're going to get 1 equals 5 minus 4 is 1x minus 0.5. Then we're going to add the 0.5 to the other side. And we get that x equals 1.5. But what it asks us is not just, it doesn't actually say find x. It tells us to find the measures of the sides. Okay? So make sure that you're answering the question. It wants the measures of the sides. So I have to know what x is, but at this point I need to plug x into all 3 of those to get the actual measure of each side. So we're just going to go ahead and start with AB. For side AB, we're going to do 9 times x minus 1, and our x value is 1.5. So 9 times 1.5 is going to give us a nice number, 13.5. Well, I don't want to do it in that color. Let's just do, so we're going to get 13.5, and we're going to subtract 1, and we're going to get 12.5. Okay, so AB is going to be 12.5, and then for AC, we're going to have 4 times 1.5 plus 1. So 4 times 1.5 is going to give us 6, plus 1 is 7. So AC is 7, and since these are supposed to be the same, hopefully our math will work out, and when I plug in BC, I should get 7 as well. 5 times 1.5 minus 0.5. So you want to put 1.5 in here. 5 times 1.5 is going to give us 7.5, and then minus 0.5 is going to give us 7, which is what we expected because they're supposed to be congruent since it's an isosceles triangle. And so first we had to find the value of x, which is what we did here in the green, and then we use that value of x, plug it into the expressions that were given in the diagram to identify or to find the measures of each of the sides. And of course, these two were congruent, so we got 7 for both of them. So that is how you do that. And now we're going to have you do your last do-it-yourself question. And once you have completed that do-it-yourself question, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.